Hello everyone, my name is Robert Chaplin. Today I'm going to be presenting on the Piper Seminole PA-44 landing gear system. First things first, something to remember when describing the landing gear system is the HEF acronym, which is H stands for hydraulically actuated, E electrically activated, F fully retractable, T tricycle landing gear. Over here is a schematic of the diagram of the landing gear, which we'll get more to in the next slide. So here we can kind of see the diagram. On the left we have three hydraulic cylinders, two for the main gear, one for the nose gear. They kind of work like an engine piston. They go up and down, and it's controlled by high and low pressure. There's those two tanks kind of in the middle where it says restrictor and pressure switch. One's high, one's low, and each of them have a line going to one of the cylinders to control that high and low pressure for that gear to go up and down. And so in the case that, let's say, our gear is stuck up and that pressure is not being relieved, we have that emergency free fall gear valve, which that little red knob in our cockpit that we move the bar out of the way and pull. Basically what it does is when you pull that emergency extension handle, it releases hydraulic pressure, allowing for the gravity of the earth to extend the landing gear. So in the case that it's stuck up from the pressure, that switch releases the hydraulic pressure and lets it drop. So if you go over to the right now, you can see the reservoir system kind of. In the middle, those two circles is the pump. It kind of pumps the pressure around. We have a bleed hole, we have a low pressure control, high pressure control, and thermal relief, and a shuttle valve. And basically, the most important thing to take from this schematic is that the high pressure switch turns a pump off when the gear is selected up, and the down limit switch turns the pump off when the gear is selected down. And the system kind of works as in, if the pressure is too high, it will relieve itself so it doesn't explode. And that emergency valve, you can pull that and it releases pressure as well to drop the landing gear. So it's a super safe system that's built to never explode for a high pressure scenario. Very smart way that Piper built the gear. So if we go to the squat switches, we have a left and a right squat switch. The left squat switch needs contact for the gear to come up. As you can see here in this picture, those two red circles are the squat switches. With it not being connected, on the ground, we cannot pull that gear up. And when you see that it's airborne, it's being pressed up, and we can retract that. It's basically a circuit that needs to be connected in order to be retracted. And when it's on the ground, it's not. But that's the left squat switch. But the right squat switch tells the tach time, and the stall warning horns go through that as well. Another quick fact about that is that there's a micro switch incorporated in the throttle quadrant, which activates the gear warning horn. A squat switch located on the left main gear will prevent the hydraulic pump from actuating if the master is turned off. So on takeoff, when the landing gear oil strut drops to its full extension, as you can see in the airborne strut extends picture, the safety switch closes to complete the circuit, which allows the hydraulic pump to be activated, like we were talking about on the slide before in the diagram, and raise the landing gear when the gear selector is moved to the up position. So now we go into the up limit switch and down limit switch. So the up limit switch gives the indication that the gear is up, obviously. The down limit switch gives the indication that gear is confirmed down and shuts off the hydraulic gear pump, so there's not any excessive pressure in the system. The gear is held up by 1800 psi, but locked down by a J-hook, over center joint, and a spring. So some gear warnings we get in the plane. We have 400 AGL below 14 inches of manifold pressure or flaps beyond 10 degrees. We get a caution. When we're up in flight and we pull that power back to 14 inches of manifold pressure and we're not intending to land, we say associated with manifold pressure, not intending to land. We turn that caution light off because it's flashing at us and very loud in the audio. But below 400 AGL and less than 14 inches of manifold, we get, and beyond flaps 10, we get a warning. And that's when we really need to pay attention and fix the problem there and make sure our gear is down and that we are intending to land or figure out why our master is going off there. Or we get a warning as well as the gear up switch on the ground. So a couple things to make note of before we get to the end here is the gear down. We have 3 green, which means the down lock switches are tripped. J-hooks push switches. There's up limit switches and down lock switches. If the pump does not turn off when it's supposed to, the extra fluid will go to the low pressure control, and hydraulic fluid goes from bottom of the cylinder to the top. So those last 2 bullet points are talking about that diagram we showed you at the beginning. When the gear is up, when moving the gear up, the hydraulic pressure will be applied until the pressure reaches 1800 psi. If the pump does not turn off when it's supposed to, the extra fluid will go to the high pressure control, and the hydraulic fluid goes from the top of the cylinder to the bottom. So think again back on that first schematic I showed you of those 2 bullet points there. And these are my sources. Thanks for watching.